can we actually register our terminal? Once we can get that working, then we'd want to see, can we establish a connection from this IP phone to the one in the cubicle next door? Once we've got basic connectivity happening, then we start evaluating voice quality. And we're going to start off using the G711 codec with constant bit rate and see if we've got problems with lost packets or jitter, and we might end up having to tune the jitter buffer, and if that starts causing echoes because our delay is too long now, we might have to start tweaking some other things. Once we have that working, then we might install some of the servers for doing things like integrated messaging and seeing, can I get connectivity from my telephone to this fancy new voicemail system and actually listen to a message. Now once we've got all this working inside the building, you might stop there, but it's not very useful if you can only call from one cubicle to another. How do you call anybody else? Well, we connect that to a public network. Most likely at the beginning of this story, what you're going to do is get a gateway and stick that between the in-building voice over IP system and the public switch telephone network. So the next thing you'd want to do is pick up the phone and dial an outside number and see if you can call home or not. If you're a large organization, you will do this at each of your locations. Then we'd want to see if we can make a phone call from one location to another location over the regular telephone network in between. So voice over IP, gateway, circuit switched regular telephony, gateway, regular voice over IP, get that working. And then see if we can short circuit between the two locations and use an IP network to connect between those two locations. And we would not start out with the premise that we're going to use the internet to connect our organization's locations together, because there are no quality of service guarantees. And there's not much point in spending all of this time and money and effort when you're going to use a wide area network service that doesn't guarantee the quality. People are just going to complain about it and it'll be a big failure. So you'd want to take a close look at using a commercial IP network, an IP VPN service, although that's better, but there's still no guarantees, or possibly a native voice over IP carrier where they can guarantee the quality to get between the locations. Once you have all of this working, then you want to go back and revisit the network loading analysis for packet loss, delay, and jitter from one building to another. And you might end up having to do some more tweaking with jitter buffers and codecs and things like that. If you felt adventurous, once it's all working and everybody thinks it's a success, then you could start doing some secret experiments with voice compression codecs and variable bit rate, so those G728 and G729 codecs. If you could get that working, then you would tell other people about it. But you want to just keep that as a little research project. You do not want to start your project with implementing voice compression. We'll finish off our discussion with some examples of applications for voice over IP and a view towards where we might be heading with this story. This diagram shows voice over IP in the call center, and this is an inbound call center. So this is one where people dial an 800 number and talk to an agent, which helps them do things, usually sell services. Voice over IP is going to let us help merge two worlds together, because we have the traditional type of inbound call center where people call an agent, dial 1-800-UNITED-1, and talk to a person who then uses a terminal to access a computer to look at flight schedules and book your ticket and ticket your ticket, and then have something faxed to you. That's one world, the traditional world. The other world is the self-serve world, in the internet where the company will have a server that you can connect to using the domain name system like www.united.com. And the server will make up some files that get downloaded over the internet, and then your browser interprets those to create GUIs, graphical user interfaces, that show up on your video screen. And then you might search for flights. What you're doing is you're filling in what looks like a form on your computer and clicking submit, and when you click that button, your computer transmits a file back to the server, and it goes through and parses that file. It tries to figure out what fields you filled in and what the contents are. Now that's a web server. It doesn't have the flight information in it, so it in turn will go to the back end computer and get the information, bring it back to the web server that will create a new file that then comes back over the internet to your computer that processes it to create a new graphic screen that comes up with the list of flight choices. And interestingly, the back-end computer that the web server is accessing is usually the same one that the agent in the traditional call center is using. Now, the problem arises when the self-service user via this web interface gets to the middle of a transaction and needs help. And with no integration between these two worlds, what the user does is picks up their phone and calls 1-800-UNITED, and then has to tell the agent all the same stuff, and they essentially recreate the user's session, and then maybe their user interface has a few more features on it where they can see what booking class and select one, and then they'll ticket it manually and fax you the receipt. What we would like to do is to have a button on the self-serve web page saying click here for assistance. And then over the IP network, the user could establish a communication session with an agent, and instead of the user losing their session, all the stuff they've done to select their flights and everything, that information will get communicated over the IP network to the agent, and both of them will have the same graphical user interface, the same web page on their screen. And so all of a sudden what we're doing now is shared screens. And the idea is that the agent could move the screen forward in the process and then say, okay, is that all fine? And the user would say, thank you. And the agent would disconnect, and the user now has their problem solved. They've been moved forward in the process. And you can imagine how much that's going to speed up the interaction process, and how much money we can save, and how much better it's going to be for users. In theory, we could do not just voice over IP, but we could do video over IP, little video conferencing. Now, I'm not really sure whether you need to see the person you're talking to if you're doing shared web pages. Probably voice is good enough. And since we're talking about IP, this means that where the servers are and where the agents are and where the customers are all independent. It doesn't matter where they're located. Also, we could have multi-tenant call centers, so that we have a company that sets up an inbound call center, and then they provide services to lots of shampoo companies and toothpaste companies. And if somebody wants to get help with what type of shampoo to purchase, they'll talk to this person. If somebody else wants to get help with what type of toothpaste to purchase, they'll end up talking to the same person. And in this multi-tenant call center, it's set up so that they get told what they're supposed to be supporting. And similarly, in the same infrastructure, we could have different groups of people serving different clients. So because we've now separated the users, the agents, and the servers into three different areas, and we're connecting them together with IP and multimedia communications over IP, which includes shared web pages, voice conferencing, and video conferencing, this explodes the possibilities for improving call center functionality and efficiency. The fact of the matter is, not everybody is going to have a headset plugged into their computer so they can do voice over IP over their internet connection. Not everybody is going to have an integrated access device which could allow us to do both